Of all the Blender features that have arrived over the last 5 to 10 years, this is the most exciting thing, at least in my humble opinion. We're going to be talking about, Polygon displacement, aka adaptive subdivision, aka adaptive tessellation, aka the coolest feature ever. This is something which is, it's really, really exciting. Something I've had my eye on for like 2 or 3 years since it was probably first talked about. And it's finally here. You can actually try it out in the master Blender build, which is really crazy. So we're going to be talking all about it. We're going to go over why it's such a game changer, how it actually works, and how you can actually start using it right now. So without further ado, let's get into it. Let me hide my face here, otherwise my face will be covering some of the words and you will not like that. So first thing to know is that it's actually 2 separate features that are sort of rolled into one release. So the first one is adaptive subdivision, which we'll talk about in a second. And then the next one is the Polygon displacement, which uses adaptive subdivision. So just to clarify, there are 2 separate things. So we'll discuss them both separately right now. So the first one, adaptive subdivision. Adaptive subdivision solves a common problem which you yourself have probably already experienced. And that's that, say you've got a scene like this. You've got 3 objects, okay? 1 in the foreground, 1 in the middle ground, and 1 in the background. And they're all identical, and they're all very high detailed. Well, if you had the same level detail as you had here in the foreground and you had it in the middle ground as well as the background, that would be a complete waste of resources, because all the way in the background there, you can barely make out the shape of the rock. So you don't need to see the tiny little nooks and crevices and things, because it's a complete waste of detail. So what you normally do in Blender right now is you select this first rock here and you turn up the subsurf modifier for this individual rock, and then the same one there for the one there, maybe you turn it down a little bit, and then in the background there you turn it down even further. Now that's not particularly time consuming if you only have this scene here with 3 objects. That's not a big deal. But say, for example, you had a scene with hundreds of thousands of rocks. That's when things get really complicated, and most artists just sort of, they do a few, maybe in the foreground, they crank it up, the ones in the background, and they just sort of leave it, and they just deal with the fact that it's rendering detail that you can't see, because that's just how you've had to do it with cycles thus far. So what adaptive subdivision does is it's this new feature, which you'll see in Blender 2.78 if you turn on experimental mode. We'll get to that. We'll do a hands-on thing. I'll tell you all about it. But you'll see there's this little checkbox there that says, underneath render, it says adaptive and then dicing scale. So what adaptive does is it reads the image and it determines which objects need more subdivision based on its location to the camera. So it'll read this one here and it'll say this one needs a lot of subdivision because it's very close. This one here needs some, but not too much. And then the one in the background barely needs any. And it does all that just by checking that one box. So it's like set it and forget it, and it's awesome. And the result is that for this, just between that and this, it's 2.5 times faster almost, 88% less memory usage. It's automatically optimized. You don't have to do anything else. It automatically does it for you, and you actually get better details, which we'll address later as well. So that's why this is so exciting. That's why this is such a huge deal, because, look, 2.5 times faster. Like, I've left the stats at the top that you can't really see them, but it went from almost a 3-minute render to a little over 1 minute, and it went from a peak memory usage of over 2.5 gig to 220 megabytes. So put it in perspective of a large scene. Normally, like, you reach a point where you can't render on your graphics card anymore because the scene is too complex. Well, with this feature, you can now, because it has this optimization built into it. That's why it's so incredible. To put it in another perspective, so it does it on a per object, like in that example, that was a per object thing, but it also does it on the object itself. So it's not like it just comes up with one flat subdivision level for the whole object. It does it on, throughout the object. Okay, as an example. So say you've got this scene right here, which has a donut shape. It's one single object and it goes from all the way in the background all the way to the foreground here. Well, standard subdivision, which is what we have currently in Blender, it would do this. You would subdivide it evenly across everything, and you can see that way in the background there you got detail that's really not necessary. Okay, well, what it does to explain sort of how this thing works is it splits it up into individual pixels. And for the sake of just visualizing this part, let's say that these are the pixels. Okay, these are the tiles for the mesh, right? So say way down here where my cursor is, it would split it up like this. And it would subdivide it on this part of the mesh. It would subdivide it that many times. And it would do this for all these other tiles, every tile on here. I'm just, for this one, just this example, it would subdivide it that many times. And then all the way in the background here, well, this one, you can see that it would subdivide it the same number of times, but because of the screen space, it's subdividing a much larger area the same number of times as this area here in the foreground. So what it results in is something that looks like this. So you can see way in the background there, those squares are a lot bigger than the squares down here in the foreground. So it's kind of like a weight gradient where it's it's subdividing really close to the camera a lot, and then it's getting less and less as it goes out, which is crazy, right? And then, but look at it, like compared to what we have currently. Look at that. Okay, so to explain why this is such a big deal. Okay, on this example of a donut, who really cares if there's detail or not? Because it's just a friggin' donut. There's nothing on it, okay? But if this was like detail with crazy detail, if this was a ground, which I'll show you in a second, this is a world of difference. This is the difference between a render taking 5 minutes and using up, 15 gigabytes of RAM, and then something like this, which is extremely light, renders way faster, and it looks identical. So I'll show you some examples in a second. But anyway, that's adaptive subdivision. And again, it's not really anything else new that you need to learn. All it needs in the future, all you'll do is just check this little box that says adaptive, and you will be sweet. It's going to be huge. Trust me. It's going to be huge. All right, so that is adaptive subdivision. Now we can talk about this second feature, which is micro-polygon displacement. So micro-polygon displacement uses the adaptive subdivision to displace the mesh at the time of rendering. Okay, so currently, the way that you do displacement in Blender is in the modifier section. Whoops. So you've got, say you wanted to make this ground here, right? You would add a subdivision modifier to give it the detail and the level of detail that you want. And then you would add a displacement modifier underneath it. You would add in the image texture here, define the strength or whatever. And it would displace it, and you would be able to view it in the viewport if you wanted to. And you can see that it's just displacing it based on the the level of subdivision that you give it right there, okay? Well, micro-polygon displacement does a very similar thing. But because it is using the adaptive subdivision, which we just talked about, it's now able to do the displacement at the time of rendering. I don't know if they are actually linked, like if the development's linked like that. But anyway, so what it's doing is you've defined it already in the modifier stack with just one subsurf modifier. You've checked the little box that says adaptive, and now in the material settings for this ground plane here, you can see the ground plane is just completely flat. It's just a flat plane. And in the material settings, all you need to do is drag the output of an image texture. You would add in your displacement image that you wanted to use right there, drag it into the displacement output of the material output. So if you've been using cycles, since it started like 5 years ago, probably, you've always had this displacement option here already. So that's not a new thing, but we haven't really ever used it, or most people don't really ever use it, because it's sort of like a grayscale bump map that doesn't really give you that much control over it. It wasn't really ever fleshed out, but it's always just been there, like this glaring, what if? It's never really fully worked, but now that it does, it means that it's able to do the displacement at the time of rendering. Okay, so this is the standard displacement. Now look at the render times at the top there, 4.5 minutes, 13 gigabytes of memory, okay? Because I subdivided this heaps, okay? Now look at this. Okay, almost no difference to it at all. And look at it. It is 2.5 times faster and 88% less memory. Crazy. This is ridiculous. You can see that the peak memory usage now is under 1.6 gigabytes total, which means you could render this on most graphics cards. So you could, the render times would be even less because now you're able to render it on a graphics card. So that's why this is huge. So micropolygon displacement is using the adaptive subdivision, adaptive subsurface, whatever, you know what I mean. It's using that across the plane and then it's applying the displacement at the time of rendering, which is really cool. But here's another thing you might not notice. Okay, so between the two of these, there's not much difference, okay? Okay, but if you look way down here at the bottom, you can see that there is some tiny extra little dots of detail between them. Okay, so it's actually more detailed. And the reason it's able to do that is that as, you know, the distance to the camera closes and it gets closer and closer to the camera, it's able to subdivide it at levels that are previously would not have been able to do because of the fact that, like, if you were to try and do it with the standard displacement, you would have to subdivide it to extreme amounts, to, I don't know, maybe 100 gigabytes of memory, let's say, because it would have to do that across the entire mesh. But because now it's only doing it for a tiny little section, it's able to subdivide just that little area to extreme amounts of displacement and get even more detail. So to show you an up close, I zoomed in on just those areas here. So standard one there. This one here at 2 pix dicing scale, which is the example I just showed you, is that. And then if you drop the dicing scale, you don't know what dicing scale is yet, don't worry. We'll discuss it in the practical example. But you can increase it even more and get it even more detailed. So that's the thing. So to summarize, you're not only getting huge savings in memory, but you're also getting faster render times, way faster, especially if you're now able to render a scene on a graphics card instead of a CPU, even faster. You're able to build larger scale scenes like that Mars scene. It would make it a lot easier without having to worry about the detail. And you're getting higher detailed materials at the end of it. So if you've ever like gone on ArtStation and you've seen somebody's material or some render or something of architecture or environment, and you've looked at the ground and you thought like, oh man, it's so detailed. How did they get that detail? Well, V-Ray and I think Maxwell, RenderMan, a bunch of rendering engines have had this feature for years. I don't know, years, maybe 3 years. That's a rough guess. I actually have no idea. But they've had it for a while. So chances are the reason why many other artists were able to make these awesome, stunning looking scenes was that they had this feature a lot earlier and they've been able to make these hugely advanced scenes. Now it's in Blender. So as someone said on Facebook, it's the last advantage that V-Ray has over Cycles, because now Cycles has this. It's finally in the big leagues. I don't know if that's a overestimation or whatever, exaggeration. But anyway, it's pretty cool stuff. Now let's do the demo, because I'm sure you are probably looking at this and you're like, all right, how do I do it? I get it. It's a cool thing. How do I do it? So I'm here in Blender, got a new scene open up. And before we start anything, I do need to address the fact that we are using a specific release of Blender, which is 2.78. This, I think within a week's time of me uploading this tutorial, it's going to be the official release, but this is an early release candidate. So if you're watching this at the time that it's released, you'll need to download the newest build or master, whatever it's called, of Blender, which is this one right here. Once you've got that, you'll go here in Blender, underneath feature set where it says supported. If you change it to experimental, you'll be able to see some new features. The first thing is that down here underneath underneath geometry, you'll find something here that says subdivision rate. Okay, these ones right here. That's how you know that you've got the right release. Okay, you'll see those ones there. And also underneath the material settings, you'll find that you've got an option to change the type of displacement. And also underneath the modifier stacker here, when we're talking about adaptive subsurf, you'll see this little checkbox here. That's how you know that you're using the right new release. Okay, so what I'm going to do is I'm going to keep it practical. I'm going to make a muddy ground. Okay, right here. I'm going to make a nice muddy surface. Now, to follow along, I'm going to use some textures from Polygon.com. You're welcome to use procedural textures or your own textures if you have them. But I do want to demo it with something practical. So I'm going on Polygon. We've got a new photo scan library here, which of course is always cool because the renders come out looking really nice. So I'm going to use this one right here, Ground Tire Tracks 001. Now, by the way, you don't have to pay to use this. You can sign up for a free trial account and you can download this right now. So go ahead and do that. So you'll want to download all of them and then go back into Blender, and we're going to split the view right here. And I'm going to load in the node editor over here and go to new. And first of all, let's start by adding in the diffuse image texture. So I'm going to go texture, image texture, connect it to the diffuse. And let's find our texture, which is this guy right here. Color, load that in. Okay, now I'm going to duplicate that just for the saving of two seconds. And I'm going to make this one the displacement 3K, this one. And this one, I'm going to load directly into the displacement, this new thing right here. Ooh, fancy. Something I haven't done for a number of years because it's now finally working. Yeah, so we're going to load that into there. And before we go any further, make sure that you select non-color data. Very important, because you want to do that for any texture that is not contributing directly to the color of the texture. So non-color data. Okay, so we load that in. And if we were to give this a render right now, we wouldn't see anything because we haven't got any light. All right, so I wasn't actually planning to plug it, but for the sake of having some easy light in the scene, I'm just using Pro Lighting Skies, but you can just add in a sun lamp and it's the exact same thing. Well, you won't get the reflections, but you get the point. Okay, so we can now see it's brown, okay, but there's nothing else really going on here. Why aren't I selecting that? Oh, okay. And the reason for that is we haven't UV unwrapped the plane yet. So I'm going to go Tab, U, Unwrap. And excuse me for one moment, I have to turn off this. You probably didn't see it in my recording, but my screen was getting getting yellow. That F-Lux thing, I keep forgetting it's turned on when I do the tutorial. All right, so we can see it there, but we can't really see it doing much. Like, look at it. It's just this displacement thing, not really that cool, Andrew. You can see the difference that it's having. It's just adding a slight level of bump. Now, this is just the default bump map, so it's kind of like fake bump mapping. So it's just adding in some shadow, but it's not actually displacing the surface yet. And the reason for that is that if you go to the material settings down here, I showed you this just briefly before, but you've got something here, a new setting which says displacement. So by default, it's set to bump, which is like the equivalent of just loading this in as a grayscale bump map and feeding it into the normal input there, basically. But you've got a new thing here which says both true or bump. So obviously if you set it to true, that's going to be a different type of displacement. And if you set it to both, it's going to be using both of them. Now, I've actually found that if you use bump, it actually creates weird shading effects. So if you set it to both or bump, at least at the time of this release, it might change in the future, but I've actually found it to give weird shading artifacts. So we're just going to keep it on true, which is the new thing, which is actually going to physically displace the geometry of the mesh here. Now, if we have a look at this, you'll see nothing. You'll see that nothing has actually changed. And the reason for that is that although this is doing the displacement at the time of its rendering, it still needs physical geometry to displace. And we only have 4 points for it to do that. So you can add more geometry a number of ways. One of them is to manually subdivide it like this. This is the way I like to do it. I just subdivide it by 10 because it's nice and easy. And then I add in a subsurface modifier over here. And this is going to be, so this is, if you leave that adaptive turned off, This is going to be just like you would be using a subsurf modifier normally. So if you go and you hit Shift Z, you can see that we've now actually got some changes. So it's actually started to displace the actual geometry, which is really cool. And if we increase this, you can see that that gets more and more detailed. So it's just displacing the physical, the actual geometry that you've given it. So now let's use that new awesome feature called adaptive subsurf. So if we check that little box there, now this view here, this value means absolutely nothing. You don't really need to pay any attention to that whatsoever, because even though if you change this up or down and it makes the corners rounded or whatever, when it goes to render, it's going to use something entirely different. So don't worry about the view there. I just set it to 0 to remind myself not to pay attention to it. Now, if we hit Shift Z to go into render mode, check this out. Boom. All right. So what it's doing here, you might not be able to notice much, but from the point of view here, the points that are in the foreground here are going to be more subdivided than the stuff, which is, oh boy, I've gone too far, way in the background. Okay, now you can't really see much in this example. If I zoom out, you can see what it's doing there. So down there, it's gone super detailed, and over there, it's less detailed. Now, how is it doing this? How does it decide where is the foreground and where is the background? If you're doing this in render preview mode, it does it from the point that you enter into render preview mode. So if I hit Shift Z here, it's going to basically apply it from here. So you could see that it's, if I zoomed way out here, like here, and another way to do it, so you can hit Shift Z and then go back into it. That'll refresh the view. Now, so from there, if I zoom all the way in, you can see the detail that it's got now is really tiny. Another way you can refresh it, and the way I like to do it, is hit Tab twice, and it refreshes it. So look at that. Isn't that really cool? So now if I go in down here, Tab twice, isn't this incredible? This is a really cool way of working. So you can change like the detail point. So it's like you're placing a camera and it's deciding it from where you are. It's really incredible. Okay, so obviously the standard way you would use it is with a camera. So let's add in a camera here. Where is my camera? Oh, it's all the way over there. All right, so I'll just hit Control Alt number pad 0 to make it from there. Let's put this camera in a little bit closer. All right, right about there. Okay, now I want to be able to, I don't know, see the detail a little bit more, or at least sort of show a better example of it. So I'm going to just split this view here for 1 second, and I'm going to hit S on this UV square here, and then type in the number 2, and that's just going to double the space that it's in right now. Okay, now you can see that it's doubled the scale of the texture, and it's because it's tileable, it's okay. But you can see it's really raised. So that's one other thing you'll probably think, like when you look at this, is like, where's that scale amount, or that displacement amount, which you're probably used to if you use a displacement modifier. Let me get a drink for 1 second. Making tutorials, it's a tough job. Someone's got to do it, you know what I mean? So you can control that by adding in a math node, and then connect it between there to there. And then you set this to multiply, and this value here becomes the scale that you give it. Now, if you adjust this, you won't actually see it happen in real time because you need to refresh the view. So if you hit Tab twice, now it's going to be refreshed. You can make it more. You can make it less, which is what I want to do. Like so, okay? Now, one thing to note though is that just like if you were to add a displacement modifier, the level that it creates here, like the level of the displacement, is based off the real scale of the plane. So if you did what I just did, which is to scale up the original plane like that, you can see the dimensions there. Here are 888. The scale is wrong. So you need to hit Control A and then apply the scale. Doing that will make all of these 1. But if you now look at the displacement, you'll see that it's nothing. So what we did was, it was treating it as if it was like amplified by 8, which is why when we removed this, if I mute that by hitting M, it was really spiky. But now that we've actually applied the scale, it's not enough. So essentially, I'm going to use this multiply value here to turn it up to, I don't know what it should be, maybe around 4. Yeah, 3 or 4 actually looks, 3.5 is actually pretty spot on. That's not bad. Okay, pretty cool. All right, now if you look at this and you go, that's cool, Andrew, but the detail is not enough. Okay, so there's a couple of things. So if you're looking at it from the render preview right here, it's going to be lower res than if you were to do a render. So if I give it a render right now, you'll see what I mean. Now, the reason that it's doing it at a lower res is just like when you have a standard subsurf, you've got the view level and you've got the render level. And the reason for that is that when you're previewing something, you generally don't want to see it at the same resolution as what you would at the render time because it just uses up too much memory, right? So it's doing the exact same thing, but the preview range is basically hidden. And it's hidden where I showed you at the start here. Down here in the render panel, underneath geometry, you've got subdivision rate. And you've got something that says render amount 1 pixel, preview amount 8 pixels. So what are these pixels? The pixels are, remember when I showed you the tile and where it would split, like depending on the tiles on the image, like the number of times it would split it? Okay, that was like a approximation, but essentially like if each one of those tiles was a pixel, this is deciding like, how many times should I subdivide it? If it's 1 pixel, it means that every single pixel on here, it's going to add a subdivision, tiny little subdivision for every single subdivision, or it's going to be a triangle or whatever you want to call it. If it's set higher, so say this was set to 2, it means that every 2 pixels, it's going to subdivide it. So essentially, the higher value you set this to, the lower res the displacement is going to look. So if I have a look at this now, you can see exactly what I'm talking about. So if I increase this to 6, or if I maybe go even further, you can see that it's getting lower and lower resolution when I do that. Okay, but if I set this lower, you can see that it's getting higher resolution. So it's basically the opposite of probably what you're used to with the subsurf modifier. But yeah, the lower you set it to, the more detail it's going to have. Now, these two rates here are based on these amounts right here. So if you want to, like, let's say, like the gap between these is too high, it means that the preview render rate is going to be 8 times lower resolution than the final render. So say I want to make them both the same, or maybe I'll just make it a little bit less than the render. So I'll make it like half the resolution. Now, when I refresh this, you'll see, you'll see that it's now higher resolution in our preview render here. And it's a little dark here, so let me just turn up Pro Lighting Skies so we can actually see it a bit better. Okay, there we go. Sorry about it. Sorry for you guys having to squint looking at your screens. Okay, so now you can see it's a lot more detailed. And if you increase, so those two mounts there, these two values here are based on the global values which are applied here. This value here is if you want to change it for this specific object. And this is really where you get to control, like, so if you, this is just obviously one object and that's all we're looking at right now. But if you had rocks, you had trees, all that kind of stuff, some things need to be higher resolution than others. So that's why you would increase this. So say you've got, I don't know, let's say it was a rock or something, you don't want it to be as detailed, you increase this amount. So I'd go, all right, I don't want that to be that detailed, I'll set that to 4. If it was just a little rock in the, I don't know, tiny rock that you don't really want to see that much, I'd maybe set that to 4. But if it was something that, I don't know, was a big part of the scene, I'd maybe just set that to 1. But ideally, you shouldn't really need to change much because it should do it automatically. And that is really the coolest thing about this. So there you go. Oh, now one other thing to note. Now, I don't think you can actually see it for this example right here. If I zoom in there, you can't really see it. Let me actually just load up an example where you might be able to see this. But there's something to note about the displacements. And it's a problem that appears because of this, because this feature is so cool, you can actually notice a flaw in the displacements now. What on earth happened there? What is going on? Okay. It's pretty weird. Oh. Did I accidentally save it? Whatever. All right. You know what? Let's just, okay. Let's say, for example, that you had a scene, the stone scene that I just had there. Sorry I couldn't get that working. Doesn't really matter all that much. But what you would see is if you look at the displacement and you can see a jagged effect. Let's try and get that there. If I set that to 1, let's see if it actually does anything. If you see a jagged effect on your displacement, it's called stepping. It looks almost like if the displacement was fed through like a pixelation filter. It looks really horrendous, okay? If you see that, it's a limitation. It's because you're seeing the displacement at such a high resolution that you're seeing the limitations of a JPEG. Okay, so you're reaching the far end of the displacement galaxy. I don't know. To the point that actually it's starting to show like the problems with JPEGs. Okay, so if you see that, you need to be using a different displacement. Preferably one which is, so JPEGs are an 8-bit image. It's still trying to load this in as extra geometry. I don't know how it's going with it. Let's see. Dun, 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 dun. Oh, for goodness sake, I wanted this to be smooth. A smooth tutorial. And instead I'm just stuck. I don't know if we'll even see it anyway. All right, well, let's just, while that's loading there. So what you'll need a 16-bit displacement, which is what we've got on Polygon. So the standard displacement file is like a JPEG, which is 8-bit, but we've also provided these 16-bit ones there as well, and it's still going. So what you would do, you know what? Forget it. I don't want it anymore. You know when you're at a restaurant and they just take so long, and you're like, you know what? I've been here for half an hour. Cancel that order. But it's almost out of the kitchen. That's not my problem. I don't know who I'm ranting at right now. I don't even think I've had that problem before. All right, so you would load in this one, which is a TIFF file, a 16-bit TIFF file, okay? Anyway, I wanted to mention that because that's a problem that some people will no doubt have. You would see stepping things like that. Okay, I'll set that back to 3. Okay, now the other thing to note is that if you were to render it at a higher resolution, so say you did a preview render and it came out great, then you do the final thing. Because the displacement, it's because the subsurface subdivision is based off the number of pixels, it would actually increase the amount of detail and the amount of memory required for the scene. So if you increase that to that, you would see more memory usage required, which is a crazy thing, but it's actually really good. So underneath here, you've got max subdivisions, which means that say, I don't know, you were rendering it at like 200%, so it'd be like 4K image, and it was just taking forever to subdivide. You could decrease the amount of the maximum subdivisions to stop it from subdividing it to a tiny, tiny, tiny infinitesimal amount that it is unnecessary. So that's what that final value there could be used for. And I think I've pretty much discussed everything that is necessary for this tutorial. So there is there is actually some final closing remarks here after the demo time. And that is that there is some limitations for this new feature. And this is just at the time of this release, okay? As always, when things are first released, especially when it's even the experimental build of Blender, not even the official supported feature set yet, things are not complete yet. So some of these things I'm sure will probably change in the future. But right now, if you've got two materials that are part of the same object, if you have a displacement on one and a displacement on the other, it won't smoothly do it between them. So as an example, this scene right here, this is a material with a tire track down the middle here, and then on the right-hand side, we have a different material. Now, I actually did something funny in Photoshop to kind of smooth it out, but I rendered it once with the standard subsurf, and then I rendered it again with the displacement, and then I cloned in or faded in the different areas so you couldn't see it. But basically, on the edge there was a huge gap, like this huge chunky cutaway effect, because it didn't smooth between the two displacements when it was on the same object. It was like you cut it with a pair of scissors and then made the levels different. It's hard to explain, but that's currently a limitation. You also have weird shading when you use the bump or the both mode. I mentioned that before, but I don't know why it does it, but it's like the normals get weirded out. It's kind of weird. Oh, another thing to note here, I didn't bring it up, but yeah, when you use, like say you add a normal map, when I first started using it, I thought something was broken, because if you use a normal map mode and you plug it into the normal input, it doesn't work. It comes out black. And the reason for that is that by default, it's set to tangent space for the normal map. If you change it to object space, it works fine again. I don't know if that's, again, a limitation or if it's going to change in the future, but that's something to remember. Make sure you set that to object space if you're doing it. The other thing, and this is going to be a big pain going forward, is that it doesn't work with particle instances. So in the example that I gave of the Mars scene with the hundreds of thousands of rocks, if each of those rocks are just particles, apparently it won't actually work for each individual rock and calculate the amount of subdivisions. I don't know why that is. I mean, you could just apply the particles. That's an easy way around that, but it won't work with particle instances. And the other thing, and this is a huge bummer right now, is that it doesn't respect particle instances' position on the mesh. So in this example here, we've got some grass and weeds over there. Again, I had to Photoshop it so that it actually looked correct. But right now, so these are like particles that are sitting on top of the ground. Well, what was actually happening was it doesn't know where the grass is like sitting on top of it. So at the render time, it rendered the ground on top of the grass, like the grass was underneath the ground. Because at the time of rendering, the heights are different for the plane. So I'm sure that's something that's probably going to change for the future, but that is a little minor thing to mention as well. But that's it, guys. If you found this tutorial helpful, please give me a like. That helps, kick something back to me. I like it when I like hearing feedback. So give me a like, click subscribe if you want to see more tutorials like this one. And if you make something awesome with the tutorial, please post it in the comments on Blender Guru. I really like seeing what it is that you guys make after following tutorials. So thank you for watching, and I will see you again in the future.